Guys, I'm back again. So now let's get into the apply middleware. But before we can get into the apply middleware, I wanna touch quite thoroughly a topic that is very fundamental to functional programming, and this apply middleware uses it not even like in a simple way, but somewhat in an advanced level, and that is function composition. So um, I I enjoyed math in high school and uni, but if you're looking for some really high level abstract mathematical explanation of what that is, that you're looking for in the wrong place. But I can tell you like in the three examples and some code what it is. The bottom line is that this is something, function composition is something that once you get used to it, you never want to go back because it's so convenient to use function composition. So actually, that is quite of the main difference. At least it used to be the main difference between Lodash and Ramda back in the days where there were no Lodash FP. That Ramda allowed you to create and use function composition, but obviously not just function composition, but a lot of other functional programming related stuff. So if you don't really count like the container types, that pretty much Ramda has everything to offer, and I think one of the strongest point is that it allows you to have function compositions, and as I said, it's along with probably like partial application and currying, function compositions is one of the fundamental stuff that it's once you get your head around the concept, it's really something that you never want to give up. So what we're talking about is essentially it's really really an easy stuff. So in an imperative world, and then there are actually dudes out there who probably can explain it a lot better than I do. So if you just want to look up function composition, the dude, I'm reading now an article from the dude that, like this Brian Lonsdorf, he's a really great guy, big on functional programming, also very humble dude. So I recommend checking out a video. Like I think it's underscore you're doing it wrong, and basically the point of the video is that they are doing it wrong because they are not allowing function composition, that in the end will make your life a lot easier. So if you're not satisfied with my explanation of what function composition is, check out this dude. He produces really good material, and not just function composition, but the whole functional programming space. So what is function composition? So as I said, in an imperative world, you might want to do something like, okay, let's assume that you have G, which is like, I don't know, some string. Then you wanna do, I don't know, you wanna uppercase it. Then save this because you need F somewhere. But then you realize that in another variable you wanna have, I don't know, you just wanna cheese. Let me. Like concat some other string onto it, okay, and then I think you get my point, but I just want to make another one, and then in the end you wanna check whether if it starts with, I don't know, S. Okay, so that's an imperative way of doing that. Like you're assigning, and we can get into what are the advantages, disadvantages of that. But the main problem is that you can never reuse these things. So if you wanna have some part of the whole part of the flow, you always have to recreate it. um, it doesn't really read well. Like, you can name the variable whatever you want, you can have the methods on it, but on its own it never really you will never really know what's going on. So these are really simple examples, but just imagine that you're not using just a simple uppercase, but you're using, so this just this part is actually composed of a lot of more like complicated calculations. So it can grow out of control pretty easily. In other words, it doesn't really scale. So function composition basically allows you to do things like piping certain things together. So if I can do something like this. So make it uppercase, and I can do it like x dot to uppercase, add string, no, the other way around. And starts with string, and this will have the same signature. Okay, so now as you can see, we kind of generalized things. So what we can do now is, first of all, like this is quite self-explanatory what it's doing, but first of all, add string will be a function, but it's not we did not hard code the string that we want to add to our target string. So the target string is x, and what we want to add is y, but you have not hard coded. The other thing is the same with start with string. We follow the same pattern with currying, and eventually with partial application. So that's one point, but it's still not the function composition that I wanted to touch on. Okay, so what we can do is, okay, actually let's make it more meaningful. Add bacon, for example, and starts with a b. Okay, so now what I can do is I can const add bacon. Now I can, I think you will get the point. So through partial application, currying, I'm composing functions of another function. So add string with bacon will not get back me any string, it will get me a function, right? So I can reuse it later. So whenever I call add bacon with a string, it will concatenate that string with the bacon. Also, if I create starts with b, can be start with string with a capital B. Okay, so now I'm pretty good, but what I want to do is, now I created these functions, I want to be able to do something like so check that we had an initial function, we composed another function out of that by just simply providing only one argument onto that. So the other argument is still, so that it returned that function basically, and when I pass another argument, it will return a string. But now I want to combine them in such a way that when I call them, all of this will be done. Like, so ideally I want to create something like const create full or what we are doing, but just create string and check for b, because we're checking if it starts with b. We want to create something that we want to compose them in such a way that first of all it will make it uppercase, and it's gonna be it's a tricky part, it's gonna be in a reverse order. So that's the first what I would like it to do. First I wanna make it uppercase, then when it's uppercase I wanna add bacon onto it, and the bacon is applied. I wanna check if it starts with a B. Like, it's absolutely have no purpose of what this function does, but you can see the point. And now that I composed this from smaller elements, I can actually have a function back. So now I can const result, and now I can put it like create string and check for b, and whatever I can put it down, whatever I want. And now I can console log the result, right? Except that we don't have a compose function, so it's gonna throw an error big time. Yeah, compose is not defined, but besides that, I think you get the point. So if I wanna give it some type defs, most of them I think it's quite self-explanatory. So it takes a string and it returns a string. Add string takes a string which returns a function that takes a string and it will return a string. Starts with it takes a string that returns a function that takes a string and returns a boolean. So add bacon is somewhat similar, right? Add bacon is a function that takes a string and returns a string. Starts with b is a function that takes a string and returns a boolean. So if you add all this together, then when we call that function, that compose function, it takes a string and it will return a boolean. So it's just simply piping through the functions in a given order, and you sort of have these pure functions, just simply like a jigsaw, like a puzzle. You're just combining them in an order you'd like them to calculate things. So okay, so what is this compose function? So the compose is basically you provide an argument. That argument will be fetched to the first function. In this case, I make it uppercase. We call that function with the given argument, and the result will be fetched to the second function, which is add bacon. It will run through, calculate its result, and its return variable will be fed to the start with b, and what will log in out here as a result will be actually the return value of the start with b. So now we need to find a way to implement this compose. So what this compose look like is, actually there is a really simple way to implement this. So the function signature would be something like compose. It takes any number of function it takes any number of functions basically, that can take any type of argument and return any type of argument. I don't know how they have that, because so the thing is that for the first function is a n-ary function, which means that you can put as many arguments as you want, and the second function, because its return value will be fed to the second function, the second, third, and all the rest of the functions must be unary, which means that they must accept only one argument. So the make it uppercase can accept as many arguments as you like, and the rest of them should accept only one. I have no idea how they use this within this type signature, so I'm gonna cheat a bit. Sorry about that. Maybe Ramda docs. Where can I search for things? Compose. Sorry, dudes. Oh, it turns out it's a bit more like bit more complicated than I thought. I said n, so they have n. Cheese. Okay. Pipe. Okay, maybe if I sorry, I have no idea what's the proper type signature for that. I think you get my point. And that's what it's doing, and we're gonna implement it anyway. I just wanna see it for myself. Compose. So yeah, it has a So yeah, it basically says that the last function, so return value, will be the return value of the whole function, and the argument that it's gonna get called with will be the argument for its first function. Yeah, so okay, that's these are much clever guys than I am. So let's just simply copy the type signatures. So what it does, it says that these types doesn't really matter. You can have arbitrary number of functions. The only thing that matters basically is that the first argument will be fetched to the first function as an argument, and the last function return value will be the overall return value of the whole function. So that's what it means basically, if I don't want to overcomplicate things. Okay, so that is compose. Okay, so actually there is a if you don't want to check for edge cases and things like that, it turns out to be I think quite an easy way to implement this, and this is basically if you have functions. So what we can do is, so we are basically telling that no matter how many arguments we have, make it an array, and because we have an array, so what it does is so the first these are these arguments, and it will get called with the value a. So it will get called with the value a, right? And what we can then do is, because fn is just an array, we can reduce it, but because the order is reversed, we're not calling reduce, but we are calling reduce right. And what we can do is, reduce signature is the sum and the current item, or the accumulator. So it looks something like, I always call it sum and item because that's, for me, it's quite convenient. So what it does, and also this is the initial value. So the initial value, I put it a. So what will it do is, the initial value in the first iteration will get into the sum, but now that we know that this a is basically the value, so if we come here to the create string and check for b, the a will be this SDS. So this is basically the value that gets passed as an argument to the first function. So if it makes more sense, we can put it like value, value. So I can put it like value, and the first item here, so this is the what I call the item, is basically the first function, so I can call it fn. So what we need to do is we need to call the function with the first item, return the result, and we start the same. So the result will be in the next iteration's value. That's how reuse works. And we will have the second function. So we just need to create something like fn that value, and basically it should give us back the value, right? So yeah, I think it's quite a lot, but if you know how reduce works, then it's just simply you have the value, you put it as an initial value. In the accumulator function, you will have the initial value, and you will have the function. You call the function with the value, and then you just simply keep iterating once you get back all the results. So if I just simply console log this, you see that now we have a false because I don't know why. What did we do? Yeah, because it starts with a B, so that's what with a capital B. So if I check, if I give it a capital B and refresh, it should be true. Yeah, it is true now. So if it was a bit too much, I just wanna give time to have it sink in. As I said, this is a really great library. The dude who's created it is absolutely pretty big on algebraic data types, functional programming and stuff. A really good library. Ramda I don't have to introduce, I think. So, and this Dr. Boolean, Brian Lonsdorf, is another great dude. So these should be enough material to learn what Compose is, but I think it should be pretty straightforward what Compose does. And this Compose is exactly what's happening with React, like higher order components. It's exactly the same pattern. The only thing that it might seem easier because you're not composing more than two functions together. So you have your basic function, which is your component, and you have a wrapper function, which is a so-called higher order component. But if you demystify all of that, it's just a so-called analogy over, because we can treat function components in React kind of pure functions because of their nature. Like the API is quite clean. They can be seen as referentially transparent functions if they are stateless. Obviously, as you have seen before, there are a lot of going on under the hood, but from the exposed API point of view, higher order components are nothing more than just function composition. So if that helps something, that if you have to associate functional composition with something, think of React higher order components the same way. So yeah, that was function composition. And now that we talked through function composition, in the next video we can get into how function composition is used in Redux. Alright, so thanks for listening, and see you in the next video.